Hello everyone, this is the relearning video for the Unit 4 Week Check 1. That is the week that we learn about scaled copies and scale factor. This will go pretty quick. The first thing we're going to talk about is, are these scaled copies? So day 1 of the unit, we talked about looking at two shapes and determining if they were scaled copies or not. And we kind of had two rules. We said they have to be the same shape, but can be different sizes, okay? So when you're looking at these, if I look at the blue and the green, well, they're similar, okay? But they're not scaled copies because they are not the exact same shape. Think of as these here as like towers, okay? These aren't as tall. Also, if you notice, the width of this is 6, and this stayed 6, but other pieces, like the height, changed. So you can't change one part and not change the other. It all has to change together, okay? All right, on the next part, it says, are these figures scaled copies? Make a table and check it. So that's what we have to do if we give you two figures and we're asking, hey, are these scaled copies or not? So the ABC one is going to be our original, and the DEF is what we'd be going to. So I'm going to make a table with original and new. So all you have to make sure or be careful of here is making sure that you match your corresponding parts. Corresponding just means that they're in the same spot on scaled copies, okay? So 6 and 9, both in the same spot. 4 and 6, both in the same spot. And then 5 and 7.5. So once you get your table made, then you're going to open up your Desmos calculator, and you are going to divide all of these backwards. Now, I just realized that I have the video only shared to this tab, so you're not going to be able to see my Desmos calculator, okay? But it's just like checking for a proportional relationship. All you're going to do is divide backwards. So you'd be doing 9 divided by 6, 6 divided by 4, 7.5 divided by 5. All of those are going to give you 1.5. So then we would say, yes, they are scaled copies, because they all the sides from ABC are multiplied by 1.5 to get the new sides on DEF. All right, let's keep going. So on this next one, what is the scale factor? To find scale factor, all you are doing is dividing backwards, new over old, okay? So 36 divided by 18, that is 2. For this next one, 15, this divided by 45. Remember, we always divide backwards. So 15 divided by 45. In your calculator, that's going to give you 0.3 repeating. And as a fraction, that is 1/3, okay? If you ever get a repeating decimal as your answer for scale factor, you need to express it as a fraction, because you're not able to put the repeating bar into your answer box. So the other way you could do that is, let's say you were dividing 5 and 15. 5 over 15, that is a fraction, okay? And you would divide both of those by 5. 5 divided by 5 is 1, because 5 goes into both of them. 15 divided by 5 is 3. That's how you get the 1/3, okay? But 0.3 repeating is kind of just something that you need to memorize as being 1/3. All right, and then so a couple of important notes that kind of go with what we were just talking about. If you are seeing that your shape is getting bigger, so if you look at this one that we did right here, this way, it's getting bigger. What that means, not biggers, what that means is that your scale factor has to be bigger than 1, okay? So either a whole number or like 6.2, 5.79. It could be a fraction where the top is bigger than the bottom, an improper fraction like 8/5. That's bigger than 1. So you can use that. If I'm asking you, hey, what's the scale factor from here to here, you're going to know that it's getting bigger, so it should be a number bigger than 1. But the opposite is also true. If I say, hey, what's the scale factor from here to here, you're actually going to be multiplying by something smaller than 1. So a fraction, it could be 1/3, 1/2. And then if it stays the same, let's say you have a square that has a 4 and another one that has a 4. Well, 4 times 1 is 4. So if it stays the exact same, it is a times 1 relationship, okay? So kind of another helpful thing that we talked about was that was this idea of reciprocal, especially when you're getting smaller, because you guys tend to see this. So you know that if I'm going from 12 to 3, almost all of you are going to tell me that that scale factor is 4 because you can recognize the relationship from 3 to 12. And I would agree that from 3 to 12, is times 4. But if we are going from 12 to 3, you can't multiply by 4 and get bigger and then multiply by 4 and get smaller. That just doesn't even make sense, okay? So this reciprocal relationship can be very, very helpful to you. If you know from 3 to 12 is times 4, then that means from 12 to 3 is times 1/4, okay? So let's say you have a problem that looks like this. Let's say it is 36 and 12, okay? So the first thing you're going to ask myself is, am I getting bigger or smaller? Well, this is getting smaller, so my answer has to be a fraction, something smaller than 1, okay? Now, you may not know what you can multiply 36 by to get 12, but you may know that from 12 to 36 is times 3. So then you don't even have to do any math or thinking. If you know that 12 to 36 is times 3, then 36 to 12 would be times 1/3, that reciprocal, okay? All right, just a couple more, and then we will be done. And this is really just using that reciprocal relationship here. So the first one here, it wants the scale factor from left to right and then right to left. So we're just practicing what I just talked about. Okay, so from 20 to 10, that's getting smaller. So if you're not comfortable going from big to small, you can go the other way. So from 10 to 20, you may recognize that's times 2. So then the relationship from 20 to 10 would be 1/2. And you could also divide backwards. If you know that your original is 20 and your new is 10, you can do 10 divided by 20. It's going to give you 0.5, which is the same thing as 1/2, okay? All right, same thing here, except this one would actually give you a very not pretty decimal, okay? So going from, if we know that our original is 4 and our new is 9, we would divide backwards and we would do 9 divided by 4. Now, when we get into something like this is going to be 2.25. However, when we do 9/4, that is an answer. So from this way, it's 9/4. Then that means that going the other way would be 4/9. You don't even have to worry about all the decimals. So all you would have to do is those reciprocals. Also, this one would give you a really nasty repeating decimal, whereas this one would give you 2.25. So don't even worry about the decimals. Just do 9/4, dividing backwards from new to original, and then flip it for the reciprocal if I'm asking you to go the opposite direction, 4/9.